Okay, we're on page 4 of Unit 2 assignment. So this is asking determine the surface area of the right cone, which is the only kind of cone we're dealing with, so just cone, to the nearest square centimeter. They give us the slant height 20 centimeters and the diameter 6 centimeters, which are these same numbers here. So we want to find the surface area of the cone. A cone has this circle around the bottom and not a rectangle wrapped around it, but this kind of, I don't know, swoopy hat shape. We know that this line here is 20, and that is called the slant height. And we know that our diameter is 6, although we're probably going to want that as radius. The radius is going to be 3. Remember, radius is always half of diameter. And the reason I want radius is because the formula we're going to use for this surface area is pi r squared, which is area of that circle, plus pi rs, which is area of this thing here. And we talked about in class where that pi rs comes from, and if you're still fuzzy on it, that's okay. The formula still works whether we understand them or not. It's best if we understand them, but hey. So that's pi times 3 centimeters squared plus pi times 3 centimeters times our slant height of 20 centimeters. So 3 squared is 9. 9 times pi is 28.26. I'll just write out here 9 pi. And here 3 times 20 is 60 pi. I don't want to hit the pi button too often. On my calculator, I'll type in 3.14. So that's 69 pi's, and 69 pi's is 69 times approximately 3.14, which is 216 and a bit square centimeters. So this is, just to be very clear, 9 centimeters squared times pi, and this is 60 centimeters squared times pi, and this is 69 centimeters squared times pi. We get 216.66 centimeters squared, which is closest to C, 217. Number 16, to the nearest tenth of a centimeter, what's the radius of a right cone with a volume of 4,353 cubic centimeters and a height of 18? So we're looking for the volume of a cone. The volume of a cone is going to be, we take pi r squared h and divide it by 3. So they tell us the volume and they tell us the height, and they want to know the radius. So we're solving for r. If we have v equals pi r squared h over 3, I want to isolate r. I can do that either by plugging in all of the numbers until I just have something equal to r squared, or I can do that algebraically ahead of time. It's best if I do it algebraically ahead of time. So if I multiply both sides by 3, write it better, 3, by 3 and by 3, these ones will cancel, and I'll be left with 3v is equal to pi r squared h. I still don't have r alone, so I'm going to do the next thing, which is I'm going to divide both sides by pi and h. Why? So I can cancel, but I got to divide this side by the same. So now what I'm at is 3v over pi h equals r squared. And if I want to take just r, I'm just going to have to take the root of both sides. So now what I'm left with is the root of 3v over pi h is equal to the radius. So I can plug in the numbers that they gave me. So this is the root of 3 times the volume, 4,353 cubic centimeters, over pi times h, which is 18 centimeters. Just to show, centimeters cubed divided by centimeters will be square centimeters. If we take the root of that, that'll be back to centimeters. That's good, that makes sense. We have to check that kind of thing, otherwise we may be putting the wrong numbers in. So if I plug those values in, 3 times 4353 divided by pi and 18, that's 231, and I take the root, so that's equal to root about 231 square centimeters, and so it's actually equal to, when I take the root of it, 15.2. And that would be my answer there, A. So the first thing I did was rearrange the formula so that I can get R all by itself. Second thing I did was plug in the values. And I guess the last thing I did was round. Number 17, calculate the surface area of the sphere to the nearest tenth of a square centimeter. So for the surface area of a sphere, it is 4 pi r squared. In this case, they give us the radius. So that's 4 pi times 12 centimeters squared. If I square 12, that's 144. Multiply by 4, that's 576. Multiply by pi, I get 1808 and a bit. Hang on. Not 8. 1809 and a bit. Square centimeters. And to the nearest tenth, I'm rounding to 1809.6, which is great because it's 1809.6. If I look at my choices here, I've got either square centimeters or cubic centimeters with the same value. So I just need to make sure, first off, I'm talking about area, so it's got to be square centimeters. Second, the other way to check, I did centimeters times centimeters, which is square centimeters. So still, that agrees. A is the right choice. Last question on this page. A hemisphere has a radius of 11.6 centimeters. What's the surface area of the hemisphere to the nearest tenth of a square centimeter? So if we have a hemisphere, that's like we've got a sphere that, here's the base of it, and here's the part you can't see behind the back. So it's a circle on the bottom. It's like a sphere, and we've, exactly like this, we've cut it in half. So we just have the top half of this, but also we've got the bottom, right? The cap on it, if the floor on it. So we need to add the curvy part, the domey part, and we need to add the base part. So we take our surface area for a sphere formula. We take 4 pi r squared. And then we divide it by 2 because we're only dealing with half of it. And then we need to add on the bottom, the floor, the whatever, which is just a circle. So that's another pi r squared. We can simplify this a bit, right? 4 over 2 is just 2. 2 pi r squared plus pi r squared. And pi r squareds are in both of these, and I have two here and 1 there. So altogether that's just 3 pi r squareds, which is 3 times pi times our radius of 11.6, they tell us, centimeters, which is squared. So we take 11.6, we square it, multiply it by 3, multiply it by pi, and we get 1268.2. And that is centimeters squared, and there we go, A. So we choose A. If we subtracted out the bottom, if we forgot to add in the bottom, you would have gotten 845. So if you chose this one, this one would be with no bottom on it. But if they're asking you for surface area of a hemisphere, they're assuming that there is a bottom, unless they explicitly say it's not there. Okay, I'll stop this video and do the next page.